It's your friendly math tutor, Miss C, here to unlock the magic of, this is a mouthful, factoring the greatest common factor out of a binomial. It's actually a lot easier than it sounds. Let's make sure we're on the same page to start with by defining what a binomial is. So a binomial is an algebraic expression with exactly two terms. So we are looking at factoring the greatest common factor out of an algebraic expression with exactly two terms. So we're going to use all of our knowledge of factoring, of finding the greatest common factor, and then factoring out that GCF. Sometimes it's helpful to think of it as undistributing. So let's go ahead and go. We're going to have a great time. All right. So the first thing I think that is helpful is we look at the coefficient of x and we look at the number 12, our constant. And we need to think about the factors of both 2 and 12. So I'm going to just make a little chart over here. Some of you probably already know the factor or the greatest common factor. But for those of us who might need to see it a little differently, I'm going to take the time to do that. So the factors of 2 are 1 and 2. The factors of 12 are 1, 2, 3, run out of room, 4, 6, and 12. So I noticed that we have common factors of 1 and 2, with 2 being the greatest common factor. So essentially, when we're factoring out the greatest common factor from a binomial, what we're going to do is we're actually dividing each term by the greatest common factor, or in this case, by 2. So I'm going to rewrite it with a 2 out in front. And then I'm going to think to myself, and I'm going to write over here on the right, I'm going to divide 2 by 2. And in that case, I get 1 times x, right? So that's where I'm going. Or just x, because in math, we like to write as little as possible. Okay? And then I'm going to go ahead and keep my subtraction sign. And then I'm going to do the same thing with 12. So I'm going to have 12, and I'm pulling 2 out of it, or I'm cutting half of 12, cutting half out of 12. So in that case, 12 divided by 2 is 6. So my binomial that had the greatest common factor of 2 factored out can be written in this form: 2 times the quantity of x minus 6. So this is an equivalent form. It just has the greatest common factor pulled out. So you might be thinking to yourself, how would I check if I were right? I think checking your answer is always a great idea. So here's how we check it. We go through a process called distribution. So what that means is that we multiply this 2 by every single term in the binomial. So 2 times x is 2x. 2 times negative 6 is negative 12. I'm looking at my original equation. That checks. So, yep, 2 times the quantity of x minus 6 is the correct equivalent binomial. All right. Let's look at this one. I'm going to try to be a little neater over here. I'm going to make a chart. So I'm going to do factor pairs for this. So I know that 8 has factors of 1 and 8. It's a factor pair, and 2 and 4. Okay, and because I like color, I'm going to change colors here with 36. Has lots of factor pairs: 1 times 36, 2 times 18, 3 times 12, 4 times 9. Oops. Okay, there's a 9 there, and 6 times 6. All right, so I'm looking at all of the factors I have in common. I see I have 1 and 2 in common. I've got a 4. There is not a common 8. So 4 is my greatest common factor. All right, so the greatest common factor is 4. So what that means is I'm going to pull or factor out 4 from 8 and from 36 to get that binomial in the simplest terms. So the 4 comes on the outside, and I'm going to do this verbally, just as another way to approach it. I'm trying to divide 4 out of 8. So 8 divided by 4 is 2. times m plus 36 divided by 4 is 9. A quick check to make sure that I picked the greatest common factor and did not make an error is I can look back at my coefficient and my constant and see if there's any other common factors that exist between the two of them. I know that 2 and 9 do not share common factors, so this looks pretty good. I always love to check my work because it's frustrating to make little math calculation errors, which happens a lot. So I'm going to go ahead and I'm going to say 4 times 2m is 8m. So that looks good. That term is correct. And then 4 times 9 is 36. Hey, can you tell me what process I just did where I was multiplying each term in this binomial by 4? If you said distribution, you're right. Math is its own language, so it's really important to make sure that we speak the language of math so we know what everybody's talking about. All right, this is our last practice problem together. So the third way that you can look at finding the greatest common factor is just using your knowledge of math facts. So I know that 9 has factors of 1, 3, and 9. I know that 33 is odd. I know that it's divisible by 11. It has factors of 3 and 11, as well as 1 and 33. So I know my greatest common factor without making a chart is 3. It is perfectly okay to use any of the 3 strategies we just did to find the common factor. Of course, if your teacher is asking you to show your work, you want to do that. So I'm going to factor out my greatest common factor, which is 3. Okay. And now I'm going to go through the process of dividing 3 out of each of my terms. So 9z divided by 3 is 3z, okay, or 3z, okay? And I'm going to do the same thing for 33. 33 divided by 3 is 11. If you prefer to write it down, you could do something like this on the side of your paper, just to make sure, and then you could see that that goes here. And then 33 divided by 11 is... Oh, why did I write divided by 11? Sometimes that happens, so I would check our work. It's 11, and you can see that goes here. Okay, so my new binomial with the greatest common factor factored out is 3 times the quantity of 3 times z minus 11. Okay, and what is the last step we should do just to verify that we did this correctly? We're going to do a check. And the way we're going to check is we are going to redistribute the 3 that we just factored out back in to make sure that we ended up with an equivalent binomial. So 3 times 3z is 9z. 3 times negative 11 is negative 33. I'm looking at this that we started with and this that we ended with. Once we did our check, that is correct. This is a correct factored out GCF. So remember, in math, we are often trying to write things in equivalent form. So we could say that 9z minus 33 is equivalent to 3 times the quantity of 3z minus 11. There's lots of reasons why we do it, but it often will make our practice better or easier depending on what we're trying to do. You're just gonna have to trust me there because you're probably not there yet if you're just learning this. So good things to come. All right, this is the last problem and this is your turn. So go ahead, jot this down in your notes, pause the video, practice factoring out the greatest common factor. And when you're ready to check your answer, go ahead and unpause and check. All right, if you ended up with the expression 6 times the quantity of 2x plus 7, you are correct. I went through and checked my answer down here, and it is in fact the equivalent form of 12x plus 42. All right, everybody. Thank you for unlocking the magic of factoring out the greatest common factor from a binomial. Till next time.